All right, welcome App School. Gosh, what number are we on? I guess the fourth number, fifth lesson. Uh, Front end, um, jocosely named Mud for the Mud God, because to do serious front end work starts to get a little bit complicated just because you are bringing in the browser and everything that gets entailed with HTML and JavaScript and possibly CSS, depending on how fancy you want to make everything, which is fine, but it tends to be a different skill set than a backend developer has, which is one of the reasons that we conventionally divide developers and web developers into front end developers and backend developers. When you actually work with Urbit as a developer, you've spent a lot of time on the command line. But as a user of software, you normally don't. Even like a Unix maximalist is in 2023 is probably not spending that much time exclusively on the command line. Now, there are certainly powerful things you can do on the command line that you can't do anywhere else, or at least not straightforwardly. But everyone's using some form of graphical computing all the time. And as Urbit, kind of the most natural way to facilitate that is to lean on the browser, because that does present a cross-platform, ready-to-hand way of graphically communicating with people. So by convention, we're going to refer to the part of the system which handles most of the heavy-duty calculations, which handles the database and the long-term storage, as the backend or the server. And there's going to be another part which primarily deals with display and maybe lighter weight calculations, which is the front end or the client. Today, Urbit mostly acts as a server. For a while, the branding that Urbit was using was that it's a personal server. That's not terrible. I mean, I don't know if the quality of it is branding. It's once you know what a server is and what a server is supposed to do, calling Urbit a personal server is actually quite an apt descriptor for what's going on. But unless you want to spend all of your time at the dojo prompt or writing command line interface apps, you are going to have to figure out how to hook things up to the front end at some point. Now, in the last few lessons, we stepped through how do you build an Urbit agent? What does it look like to have an Urbit agent? What does it look like to interact with that Urbit agent through pokes, peeks, and subscriptions? And then last time we started looking at how do we move data in and out of Urbit using conventional formats that are not Urbit native, as it were. In particular, JSON, JavaScript object notation files. We're now going to turn our attention to putting these pieces together in such a way that we can talk to the place where your data are likely to originate, which is going to be the front-end interface. That doesn't have to mean a browser. We have written, there's a tutorial for Lick that hooks up to a Pygame Python interface. There have been other things that people have experimented with, but 99% of the Urbit apps that people have written talk to the browser, because, as I said, the browser is a good cross-platform way. There's a lot of tooling that has been built for that, JavaScript packages and so forth. And on the Urbit side as well, Urbit fluently speaks network protocols, HTTP, HTTPS, and is comfortable manipulating XML, HTML, and JavaScript. So we're going to build a front-end interface, works in your browser. We're going to move fast and light. We have a full stack walkthrough that goes into a lot more detail if you'd like to get deeper into that. Next Friday, I'm going to do a different, this isn't part of App School. It's a follow-on series called App Workshop that I'm running once a month, where we will get into some of the other details involved with hosting, more complicated apps like JavaScript web app games from your Urbit ship. But today we're going to see the elements of how to do that. We are not going to get very deep into HTML or JavaScript. The lesson is going to assume that you have some facility with reading them, at least that you can look at them and cribbing off of Python or C or what else, whatever else you may have seen in the past. It doesn't look like gibberish to you, but we're not going to teach React. We're not going to teach JavaScript. React is the JavaScript framework that almost everyone who writes Urbit apps ends up using. But then there's some tutorials that I'll direct you to as well that will give you a little bit more background there. Now let me go ahead and share my VS Code interface and we will proceed. Let's see, we want this one. We want, let's see the participants list. And I want the chat open. And I'll go ahead and close that. All right, you see enough of my screen that this is the notes from last time here that we have. Let me know if it needs to be bigger or something, but I think I'll leave it here. All right, I have a version of this. It's already set up. I ran through it yesterday, and the lesson notes as written actually work fairly well. These things can change from time to time. So I'm going to move you don't need to do this. I'm going to move my old file out of the way, just so I have this out of the way, and you can follow this. All right. We are going to build the React front end using Node.js. Node is a system, it's a package manager system for building JavaScript apps. These can get very complicated. JavaScript, it's trivial to import modules and use that to do various parts of your interface, but they balloon in size very quickly. And so sometimes it takes a surprisingly long amount of time to build these things. So if you have Node installed, you should be able to type something like npx and get, yeah, see, I don't have anything to do here, but it did run, so I'll do Control D and jump back out to my regular prompt. I think Node, yeah, same thing. So Control D exits that for me. Those both give you interactive interfaces there. So we're going to install @urbit faz create landscape app. And this is a package that has been written to set up most of the boilerplate for you that is necessary when you're working with an Urbit app. We're going to name it Echo, Alpha Bravo Charlie Delta Echo. And we are going to, what URL do you use to access Urbit? I'm going to say localhost 8080 since I'm going to be working with this locally. All right, so now there is a new Echo directory that is present in my folder, CD Echo. I look around, I see there's a desk and there's a UE. If I look at desk, I can see it has a desk.bill, a desk.docket, and a sys.kelvin. No other folders, so this is not enough to actually build the agent that we're going to make Echo. If I ls UE, then I can see there's an index.html and a bunch of other bits and pieces in there. We're going to cd into UE, so we are now in Echo UE. Actually, let me give you the npx component there as well. All right, so that's our first one there. We're going to go into cd echo UE. And then we need to install the Urbit HTTP interface. npm install pat urbit faz HTTP HEP API. all of this that we're doing is creating an empty web page that our Urbit ship will know how to talk to. We'll still have to set things up. Ultimately, what we're going to do is we're going to take Delta. So you'll recall Delta let us poke ships, and it supported subscriptions so that one ship could the Delta follower could watch what was happening on a particular Delta, but it just let us push numbers onto and pop numbers off of a stack. Echo is going to do the same thing. The difference is we're going to set it up to be able to talk to the web front end as well. And as it will turn out, we don't need to change a whole lot from Delta. The pieces that we've acquired over the past few lessons have made it straightforward for us to write an interface that just shows the contents of what we need to proceed here. Now, it has run HTTP API and has a complaint about Vite.js, but not my circus, not my monkeys as far as keeping that up to date goes. In package.json, we need to add an entry. This is going to be home page, and we need to tell it that we're going to load it at apps echo. So this will be the line that we add in package.json. All right, so we have those. Daniel, you're just coming back in. We installed HTTP API, and then in package.json, we're adding a single identifier line here if you are following along with the steps here. All right, so at this point, all we've done is we've created a blank web app framework. We're going to need to hook up our Urbit ship. We're going to need to figure out how to serve it from our Urbit ship, but we've built the pieces of the framework here. I think there's like an npm build or npm install stuff that we'll have to do in a minute as well, but we'll worry about that in a minute. All right, our backend. Delta was this agent. Most of these arms were either boilerplate arms or they're arms that we're familiar with at this point. So on poke accepts a push and a pop. That's a Delta action, etc. What we need to do is since Urbit communicates using regular HTTP, it needs to be able to communicate using GET and PUT calls. So the way HTTP works is it sends a request to get information, which is analogous to a peek, or to put information, which is analogous to poke. HTTP API is built to work with React. You can build other frameworks, other arrangements if you're willing to figure out how to make those things join up correctly. But the easiest thing to do to get started is to just say we're going to use HTTP API because it knows how to talk to an Urbit ship. It has the API built in for the JavaScript language side of the equation. So now we need to look at the Urbit side of the equation, and we'll figure out how to get those two things to talk to each other here. Air is going to be the HTTP server vein of Arvo. It receives and handles GET and PUT messages. The web client is responsible to produce a unique channel ID that's going to subscribe to your Urbit agent. So basically, the way that those will come in will be handled in OnWatch, and then you will return GIFs, and Urbit will figure out how do I transform this information back out to my browser. How do I get it to speak JSON for the browser, essentially? We are going to copy Delta. We're going to update it to have a small front end, which displays the state and allows us, it's going to have buttons to push and pop values that will correspond to our pokes. The pieces that we have from before, so we have a structure file. Let's go ahead and go back up here. All right, so now we are in Echo Desk. And we can, if we ls, we see there's a desktop build, there's a desktop at 0, and there's a syskelvin. There's not enough here to do everything that we need, but we can go ahead and make a SIR, make a mar and a mar echo, make an app, and then we'll fill in these pieces here. So let's go ahead and copy. This is the contents of SIR echo. I should probably get, now that we're getting more and more of these, I should get in the habit of putting these at the top here. So this is SIR echo. There is no difference in this file whatsoever because it doesn't even refer to the name Charlie Delta Echo, whatever. Like this just is these values here. I mean, we've seen this file written a couple of different ways. This one just includes entirely the action inside of the update. We've also have a version where we've explicitly copied the push and pop down, but they both come to the same type in the end. So let me go ahead and save that as echo desk SIR echo.hoon. All right. Now our JSON, we want to handle JSON that looks like this. So we are going to be receiving from the browser either a push that includes a target and a value as what JSON calls array, or I guess associative arrays, where you have a key associated to a value, and we have a list of them, or a pop, which simply has a target. So you can see how this maps directly to what we're interested in from the action type. One change we are going to make is we're going to take what we knew about JSON. So this will be mar echo action. And this one is going to add not only just the noun arm that we're used to, but we're going to add a JSON arm. And so this one is going to be able to receive a JSON and produce a regular action type out of it. So this is going to be a regular echo action. If you look at what's going on here, you can compare it to what we saw when we looked at how to build JSON reparsers before. The target's going to be processed from a string to a PAT-P. The value is going to come in as a number, and we're going to parse it into a PAT-UD. This comes in as a map with the head push, and so this whole type gets unpacked as a regular push. Pop, same things happens, but we're gonna unpack it as a pop action type. Because we're putting this straight in the mark, this will be taken care of for us automatically. We will simply receive, if any data comes to us as a JSON, it will automatically get converted by Gall, error, and then Gall into an action before our agent ever sees it. So our browser can speak JSON, our agent can speak nouns, can speak echo action types, and the mark automatically handles that conversion in between those. So I'm going to go ahead and save that as desk mar echo action.hoon. And there was an update type as well. So let me go ahead and copy this. So this will be mar echo update. This one looks different because this one is producing pop in it or push values, and so it uses these like weird frond and pairs values. The short value is they have like this semi-tree derived analogy. This is just incredibly dense code at the end of the day to this domain specific language. So I recommend using John, which is the generator that I talked about last time, where you can give it an example and it will attempt to produce a reparser or a JSON manufacturer arm. Either way, let's see. I should give you both of those. That's Echo that I just posted. That's mar echo update, and then this is mar echo action that I just posted there. And SIR is identical to the SIR we had from Delta previously. Update.hoon. All right. And here is our app. It's too long for me to post, but this is actually the same agent as Delta, with the exception that I didn't rename everything to a list card the way that you're used to there, and it says Echo everywhere it said Delta. So you can find and replace Delta with Echo, and otherwise this is identically the agent that we were working with from Delta. No other changes have been made. You can verify, you look at onPoke. onPoke does the things you expect onPoke to do. onPeek accepts the values, onWatch handles update inits and so forth. Everything else is the same. And this is what's going to be neat about this, is this agent that we've already built will just be able to be hooked up to a front end. So I'm going to go ahead and save that as app echo.hoon. So that is Delta with name changes. All right. We can also do more sophisticated things. So by default, this will point to apps echo. So if I wanted to access this, I would go to, my local host 8080 apps echo, and that'll be the interface that I'm at. Some of you may have noticed, if you've played around with other agents, that not all of these follow this pattern. So for instance, pals is directly after your URL and port name. You can register these arbitrarily in AIR, and right now we haven't had any limitations on this. What they're probably going to do in a future version is it'll probably go to something like, I guess it would be something like echo.localhost 8080, and that would be the main endpoint for that. So someday that will change, just so that every agent or maybe desk, I don't know if they're going to do by agent or desk, this has all been in discussion, but it'll give us better namespacing, because it'll prevent us from explicitly registering some other agent's name here. Since right now you could do that, you could squat on some other agent's name. All right, and let's see, let me open. Let's see, this is Echo. Where am I here? I need to orient. Okay, this is all in the Zod. I don't need to be in the Zod. I need to be here. And this is desk docket 0, which right now is the empty boilerplate. And here is a more complete version of that. All right. What is a docket file? The docket file is the registration that tells Grid, which is your main installer when you open up an UrbanShift for the first time, and you get that, you get the layout of icons of the things you have installed. This is what registers your agent for Grid, so that it knows how to load a particular, how to configure the app tile, and it knows how to load whatever front-end files you have and so forth. You're going to give it a name, which is its title. This is another instance where what's actually being said is this. And there's this shorthand where you can head tag things with a less beforehand like that. It does save you some keystrokes. I think it obfuscates a little bit, so I've been avoiding it in App School, but there you have it. we are going to have, all right, so base is your I think it's your URL, like apps echo. We aren't really worrying about versioning, licensing, website, just leave those the same. Glob is kind of an interesting piece. We're going to get deeper into this when we talk about publishing agents in 2 weeks. But the glob refers to all of the files you need in HTML, CSS, JavaScript to make your front end work. We are going to upload them. It's kind of like a zip file. Like we're just going to upload them as a folder containing all of these bits and pieces. And then we'll be able to serve it from our Urbit ship. So this part here, this URL, I believe this automatically gets replaced once that happens. So right now we can just fill it with this boilerplate line, but those files can be served 3 different ways. So one way is, so this is glob stuff. All right, so one way is glob HTTP, and this means that we have built a traditional site and we want to just directly upload it to our Urbit ship as a bunch of files and let Urbit serve it, act as a server, the same way you would with Nginx or Apache or something else, where it's a bunch of files that are sitting on the server. Urbit knows how to serve them to a browser that requests them, and therefore you're going to be pulling your copy of them over HTTP. There's a similar one, glob AIMS, and this one applies when you want to distribute everything over AIMS, which is the Urbit peer-to-peer network. Glob AIMS is not preferred right now for development for a couple of reasons. It works fine, and many apps do distribute. But number one, fake ships can't see AIMS. They're not on the live network. And so fake ships can't install all of your app. If you're, so you'd have to build it from GitHub, and then you'd have to run all this NPM install bits and pieces like we're having to do here. And 2, AIMS is not as fast as it will be. HTTP is faster. And so, for installation purposes, it's faster to do things through glob HTTP. Then the third one, and I think the shorthand for it is site, and this means that we're going to serve from Urbit directly. And that means that we are actually building the HTTP, or excuse me, the HTML site in Urbit code, and providing this to our browser. Pals does this. Rumors does this. There's a few others out there. If you've played with like Score, Handful DevNet had like Slam, which was I don't remember if Slam did actually. But there's a number of these that you're actually serving something from Urbit. Like Urbit is where the site is built. It's not built as external content, like Urbit generates it internally. We will briefly look at how to do that at the end today, and I'm going to try and do it in more detail in a later lesson, if I can think of an elegant way to present the material. Building HTML from Urbit is a little bit odd, not unprecedentedly odd, but a little bit more involved than just sitting down and coding HTML by hand, for instance, would be. So that's what the glob is. The glob is the actual front end files. All right, so let's see. So we have a desk. Oh, that's the wrong one. All right, so we had a desk docket. We did that. There'll be a desk.bill. Right now that's empty. So this is supposed to be a list of the agents that run when you install this for the first time. So we can add this. We can add our echo agent here. And then we need a lot of docket marks. All right, so if I ls what's here, I can see there's app, there's mar, there's sur. There aren't any lib files, for instance. So if I want to put all these into Zod or Neck, then I'm going to have to include everything that's involved with this. We've run into this before. You can either cherry pick over exactly the files that you need and just bar commit over and over again until you get the actual pieces you want, or you can just copy everything from somewhere else and make everything work this way. What I'm going to do is I'm going to copy everything in let's copy everything from zodlib here. It's a lot. It's more than we need. If you go open up the folder lib, there's a lot of pieces in here we don't actually need, but for our current development purposes, that's fast enough for us. We're going to need mar, so I'm going to copy that to mar locally. We're going to need sur, so let me copy that to sur locally. And libmar sur, we shouldn't need anything from app or gen to make this work. Let's see if this gets us all the way there. Actually, it won't, and I know why. But let's run it and see what's going on. I'm going to run neck this time. And if you haven't updated your binaries, there was a new binary that was released yesterday or Friday, like very, very recently. There was a released. You can run next, and this will go ahead and download and install, upgrade your local one. So ./zod.run next like that will give you that next version. And so I'm going to run neck instead of Zod because I already installed this on Zod, and I want to actually show you the process here. All right, so I'm going to run neck. All right, I need to create a new desk echo, bar mount echo. This is all stuff we are familiar with. And then over here, I need to copy everything in Echo Desk to neck echo. I need to copy recursively to get everything. Yes, 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 yes. Okay, everything's copied over. I go to here and I bar commit echo, and it's going to attempt to load a whole bunch of files. I get this whole list of files, and it will fail on validating desk docket 0. It turns out, through a quirk of history, that the docket material is actually formally, it's not part of the base desk. And even though it comes with your Urbit chip, it's not considered part of the Urbit distribution. It's actually considered a Tlon product like groups and talk are. And so docket doesn't live on base. It lives on another folder called landscape. So I'm going to bar mount landscape. And then we are going to need to copy over, let's see, I'm in neck, landscape, mar. I need docket 0 in my mar. I need lib docket.hoon in my lib. And I need sur in my sur. And let me give you what a slightly different version of those would look like if you were working with a Zod in your home directory, wherever you need those to be. And if I bar commit echo now, hopefully everything builds. What I do? Oh, I did not also copy these to neck. Okay. And choose on it for a minute, and looks like that succeeded. It's a lot of extra files we don't need. We could clean those up in a distributed version, but we won't worry about them for now. All right, let's see if bar install our echo works. Done things correctly to this point. This should boot. Okay. It tells us it was fetching, Docket tells us it was fetching HTTP glob. And so it's just grabbing some generic empty set of front-end files for the Echo desk. And I should be able to poke echo with a PAM echo action, push, let me do neck, because I'm on neck instead of Zod. Push a few numbers on here so I have some values. And I can do col echo less debug and see, okay, I have 4 values in my stack right here. Now, if I go to, let me share my browser here. Let's see, you should be able to see that. All right. If I go here, you can see neck and it wants the access key. So go back and do lus code at your command line. On neck, this will always be a standard, it's on any fake ship, it's always the same standard pieces there. So I hit continue. And it will go ahead and load grid, which, as I said, these are all populated by the desks that have Docket files associated with them. And sure enough, Echo now shows up, and the others like Delta and Charlie would not, because they're not registered with Docket files. If I click on it, however, it does take me to apps Echo, but then nothing shows, right? We have an empty front end. So right now what we have is a situation where we have a front end and a back end. And in principle, the back end speaks JSON and the front end should speak JSON, but we don't have any communication between them. They don't know how to talk to each other. So we're going to need to do a little bit on the front end and a little bit on the back end to make this work. Back to, yeah, this one. Okay. Now we need to go back up to UE. So if I PWD, I am in AA App Academy, but App School, Echo UE. And I'm going to run npm install. And it'll run through, and what it's going to do is it's going to produce a source source is still not a npm build. Means it pulls in all the node modules, and then we're gonna build based on the contents of source. But now we need to actually change some things. And the message is too long. Let me show you what the code looks like, and then I will create a gist really quick and share that with you because it's a little bit more code. UE source, and we're going to go to app.jsx. And so you can see this default one that's sitting here, it knows to import Urbit, and what it actually does right now by default, if it doesn't do anything else, is it shows a list of your Urbit's installed apps. it requests a list of your Urbit installed apps and just displays those values there. And you'd have to go look and see, okay, where, how is it finding this list and so forth. Like these are things that are pulled in from Pat Urbit FAS API. These are the JavaScript modules that have been installed for us as part of this. And so it knows how to connect to a particular ship. It knows how to do things like scry, api.scry, and you send it some values and it finds those value, those quantities for you. All right, so it'll know how to grab and manipulate those things. What we actually want to do is we want to replace it entirely with this content. And let me do that just real quick so I can share that with you. All right, that is in the chat, and I will paste it here as well. So this is going to be echo UE source app.jsx. You're going to replace it with this contents. Now, most of this is ways of handling quantities that we're getting back. Shift and unshift are JavaScript operations here. If we're looking at the actual page we're going to see, return is going to actually build and show us this page. It's not very long. This is the entire page we're going to see. So there's a main tag. There's going to be an input box. And when it changes, it's going to call this set input value from the target and the value. So it's going to want to know the target and a value. And if we go look at where's one of these goes to I guess we associate it with the buttons here. Yeah. Okay. So then our buttons, one of the buttons is associated with push. This whole syntax here is the React framework's way of associating these quantities together. So the HTML that's generated won't look exactly like this. And it's one of the reasons that we just say, if you're going to do heavy front-end development, it's worth your while to just learn React and use that as your basis there. Because it doesn't even look like vanilla JavaScript here. But we're going to associate push with one button, which is going to be able to acquire e.target and value. And we're going to associate pop with the other one. Push is going to build an API and poke the API with a JSON through the echo action mark. That's going to have push, target, value. Pop is going to poke through echo action with pop window.ship. Right? It didn't have a separate label for target. It just had the actual target. And then it's also going to print a map of each value that it has. So it's going to produce an LI, a line item, and with the index as that key. So if we examine the line items, that won't show up. But if these were in a numbered list, for instance, and these are I believe these are in an unnumbered list in what it's going to produce automatically. But if it were a numbered list, then it would show up with the index values here as the keys to the value that results. All right, so that's source app.jsx. And then how the JavaScript hooks up to it. All right, let's see. We are going to need, okay, so that's saved. All right, I'm going to do npm run build. And what npm run build will do is it'll produce a dist folder. So this will be echo UE dist. So this is your distributable folder. These are going to be the actual resources to be used as the front end page in Logic in Urbit. cd dist ls. Actually, I can do tree and see what's in here. Like it's not that much, right? There's a default fav icon, a little bit of JavaScript and CSS that got generated, some Safari specific stuff, and an index.html. So I could come up here and I could open index.html and see what's in it. This is the actual contents that was generated. So there's a lot of header junk. And then the div ID is app. App is what is actually pulled in from the JavaScript there. We do need to make a couple of very small changes. We need to mark these scripts as modules on lines 12 and 13. So that's the desk.js and the session.js values that are going to get loaded in there as well. And you'll have to do this every time you run npm run build because it's going to overwrite everything in this folder. So it's still kind of this awkward extra step that we have. There might be an upstream way to fix this, but no one's bothered to do it, and I'm not enough of a JavaScripter to tackle it myself. All right, we should need to do nothing else on the back end for this. But what I do need to do is glob it now. So let's go back to our browser and I'll show you how you glob something. All right. So we're going to go to our local host. We're going to go to docket/upload. On a Mac, the default port is different. I don't remember what it is, but it's a different default port. All right, so what this is going to do is it's going to allow us to basically batch upload a front end for some particular desk. So this is going to put all the data in our Urbit. So I need to go to echo UE dist, and I want to select dist. Am I sure that I want to upload all files? Only do this if I trust the site. I do. And so it lists 5 files selected. Fantastic. And hit glob, and it should tell me that it successfully globbed. And if you watch your terminal at the time, nothing happens. This doesn't generate any additional content here. Now, however, when I go to grid and I click on echo, look what happens. It has requested the information via JavaScript, unpacked the value from the init tag, and displayed it for us here. And so now I don't actually have 2 inputs here, one for target, one for value. I only have one for value. If I recall correctly, I think the homework for this one is to add the one for target. So it's going to be making a couple of specific changes in the file that are very closely analogous to the other lines that you have. And you should be able to, hopefully ask for help because it's all weird, but hopefully the analogs of the lines that are next to it are close enough that you can figure out what to do, even if you're not familiar with JavaScript or React. On the other hand, if you get totally stuck, we're looking for 7 of 8 homeworks, not every homework. So this is one that sometimes gets skipped. All right, now I can push a value, and it takes a moment, and then it updates. And if I were to go back to my Urbit ship and run echo less debug again, I would see that 2520 so forth is on there. I can pop a value, and these come off. So everything that I was doing at the back end, I can now do through a proper front end and get the same behavior. So the ability to build a front end and a back end that communicate to each other through this one particular interface of just having JSON objects that are shaped the right way is pretty neat. You know, it wasn't free. It required us to figure out how to build a reparser and how to produce a JSON as a result. But we can, you know, hook these things up to each other. There has recently also been introduced the ability to have what are called noun channels, which means that you can write something that speaks Urbit nouns, you know, like binary trees, and can talk nouns back and forth through pokes and peeks and subscriptions and so forth. And there aren't a lot of examples that use it yet, but it will let people sidestep JSON if they don't want to use JSON in doing this. On the other hand, with the browser, browsers speak JSON natively. It's probably not as useful with the browser. There are some Urbit noun libraries that are getting out there. If you're working with another language like Python, then noun channels can be incredibly useful because you can write something that just speaks a noun channel instead of JSON and then talk to an Urbit ship directly. And actually, the latest base update, the latest Kelvin decrement that's coming out on the, I want to say the 29th when it's actually going to hit. It's the one that's associated with the runtime that's coming out right now. Although it might hit sooner than that. I don't remember what the actual timeline was. That one has support for what are called open air channels, EYRE, like everything else. And that's going to allow you to treat clients to use client sessions in the browser that are associated with ships, or if they're not associated with a ship, then you can treat them as associated with a Comet identity. And so you'll be able to build Urbit-based front ends that, from a regular legacy web perspective, look and behave just like Web 2 applications. That, you know, you can just have a regular session talking to it. You could use this for like a comments section or something like that. So there's some interesting developments that are happening right now, which will increase the power of what we've been doing with, can we, you know, use Air to get a browser to talk to an Urbit server. Let's go back to VS Codium. All right. Another thing I'd like to show you, so the app.js. Oh, actually, let's look at what the actual code in the browser that was generated looks like. So view page source. No, I want the inspect. And it's so tiny. All right, so here you can see there's the main tag that was generated. Here's the input. Here's the div with those two buttons that we were talking about. You notice that they have an event associated with them, which is the push and the pop functions, but they aren't written the same way that the React framework had us do it. Then there are, you know, the various entries here, so I can push a value and I can see that the change update in both cases. Interestingly, it's also stripping out the key equals index part of that. I would have expected that to stick around. But anyway, you can see this direct mapping between what's going on here. Now, from an Urbit perspective, let me do Hastebin here. All right, so we were writing HTML that looked like this. Had a main class, had an input, had a div, blah, 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 blah. Urbit has a native representation called Sail. It's technically Urbit Native XML. So, you get tag with attributes, so you can represent things that aren't HTML using it, but it's really built intended for HTML. It is going to use a more compact syntax than HTML. This was one of the big criticisms of HTML. And so it resolves this by not having to you have to close tags, but you don't have to like worry about getting the nesting and everything like quite as correct with it. But it has its own syntax. And so the same code in Sail would look like this as Urbit code. It's preceded with a semicolon, and then there's a pairing tis to mark the end of it. And then the attributes are listed as a comma separated key value pairs. And you can this is a little bit weird because I'm trying to write React inside of it to make that work. Anyway, so the JavaScript elements are not present here, and so they can be manually included using a script tag in Sail. I've seen this done. So Little Wolfer has the Fart app, which is a fork of Rumors. But what it does is have some JavaScript that is explicitly included as a tag. So you have a script tag, and then it has that contents there so you can see what that looks like in perhaps the most ignoble of Urbit apps that has thus far been written. Writing interfaces, Urbit native interfaces, is a little bit clunky. It's not really because of Sail. Like Sail actually just is fully featured HTML. It's just a different representation for it, which is not unprecedented. Other languages have done similar things. Clojure does this, for instance. But it's hard because you can't dynamically serve page content without JavaScript in a modern browser. So there are some libraries that will help you dynamically build content, like libschooner.hoon. Libschooner.hoon. This is a Quartus third-party library that provides a lot of wrappers for HTTP responses. This lets you serve a lot of MIME content. So if you need to serve an MP3 file or a PNG or whatever, then it has handlers to go ahead and serve those. So there's a couple of applications in the app workbook on developers.urbit.org that detail how to do that. We may come back around and take a look at that in one of the later lessons in App School if there's interest in that. There's also Rudder. Rudder is a rather complicated. So let's see. So that's libschooner. There's also Rudder, which is so this one's by Quartus, and then Rudder is by Paldev as well. Paldev. And it's really built for Sail-based interfaces. It has three arms, which are like there's a build, the build arm for GET requests. There's an argue arm for post, and there's a final arm. I guess it's post, but both of those. And this is the way that Pals is built, for instance. Ahoy is built this way. There's a few other apps that are built this way as well. We won't get to Rudder because it's rather complicated in App School, and most of you are probably not going to build Urbit native apps. There's also the Goon, Hashtag Dibtux's proposed Urbit native interface layer that will automatically build dynamic web pages and other things for you. That has been demoed successfully at the developer week back in, I think it was May or June, and should be coming along. So we should have more sophisticated Urbit native production of these things without having to build everything in JavaScript and then you sort of hook these things up to each other. I don't think it's terrible to hook these things up to each other mechanically. It's just making sure that your two parts can actually connect to each other. They can talk to each other, which we just did, right? We wrote Echo as a direct modification of Delta, just rolling the the JSON reparsers into the Mark file. And other than that, we essentially had to make no changes to our backend. What we had written just worked. Urbit is a personal server. It's actually very well built as a personal server. Writing a front end is just sort of always complicated, but that's just because front ends are complicated. And that's true no matter what platform you're using ultimately. Now there's a question in the chat here. Can we run a dev build of the React app on localhost and still globulate? Maybe. So I guess if you're doing npm run start, that's where it's rebuilding every time you make a change. Is that correct? Is it that version?
Yeah, so you can see live changes of your JS changes browser. It'd be useful.
Mm-hmm. You would still, I believe you would still need to globulate every time you made a change. And I don't think there's a way to set up like a watch or an auto commit that would automatically handle that for you. The people to ask about that are like Knox6 Lassell at Tlon. Knox6 Lassell. Tlon has the most experience building user interfaces, and they maintain a lot of the React infrastructure that gets used on this because they're the primary users of it. So they're going to know a lot more about what that developer workflow looks like. I know enough JavaScript and HTML to get myself in trouble or to build really ugly web pages, but I'm by no means a front-end developer. But I do understand how to get the parts to talk to each other at the end of the day. Other questions?
Yeah, I have a question. Maybe it's a bit of a silly one, but after kind of watching you develop an app and stuff, is React actually, is it necessary just because kind of Tlon uses that, or like can we use other frameworks? So that's not a good idea.
You can. Urbit Forms, which is not currently maintained, although I'd like to go back to having it maintained. It's basically a Google Forms clone. Is built using Svelte, SVELTE. So there people have built other using other frameworks. I don't remember. I think Urbit HTTP API is not React dependent, but so you can definitely build using other front-end frameworks if you want to figure out what that looks like, but we don't have a lot of good examples of that that are public. There are a few.
Yeah, because I saw there's one with the JS game, and I'm actually working through it. I haven't seen React in it yet. It was just JavaScript, really.
Is this Flap?
That's the Flap one, yeah.
Yeah. And well, see, that one's kind of a very minimalist one in that we actually don't do anything with the JavaScript at all.
Yeah.
Until I think we do export. There's an export step where we make it send a JSON of the score, and I think other than that, we don't even touch the JavaScript. So yeah, it can be pretty minimalist in that sense.
Okay, so it is possible then. Okay.
Mm-hmm. Yes, I mean it can talk to anything that speaks HTTP ultimately, and then all the JavaScript stuff is just making it dynamic for the browser and so forth. from Herbert's perspective, HTTP is and maybe JSON is the part that matters. There's another question here about TUI's text user interfaces. Would you like to elaborate on that, Daniel?
Yeah, it's was wondering about other kinds of front ends that don't involve the browser.
There are some examples. I mean, Dojo obviously is a text user interface. There are a few others that have been built out there. If you go to the developers.herbert.org guides, there's an app workbook section that lists a couple of them, like Track7, and there's another one I can't remember what, RPN, Reverse Polish Notation Calculator. And it shows you how to build, both of those show you one way of building a simple TUI interface for this. You can build more complicated things. Paldev Palfin Foslip has demoed these from time to time. He likes to get in and mess around with them. It would be nice to have something like a libcurses so that we just have a toolkit that people can use, but we don't currently have something like that out there. So
Thank you.
right now, the simplest thing you have is you can write a prompt that is parsing input and producing actions. There is, let's see, where is this? This is in the this is in TUI Toys branch, which is
Yeah, Paldev and I have talked about implementing curses for years, but neither of us has enough time to do it, even though we have the theoretical experience. I've done a lot with curses, but it's just time.
you've done everything but written it. Maybe you
Well, I mean, I've written a lot of even curses libraries in Ruby and in C, but it's just, yeah. If any of you have several $1 million and want to buy my startup and then I can retire, I promise to work 100% of the time on Urbit and do just console work.
I would actually like to see more done with CLI stuff. You know, it would be a lot of work, but I think like implementing a Z interpreter, which would give you Zork, things like that, I think would be not too far out there. Anyway,
well, in some ways, the way that curses works is very Urbit-like, right? Like the whole idea of, you know, it just makes a pass, and it's a curses interface is basically a static interface, right? That updates every single time, you know, an event happens and then you update the page, the screen, right?
Mm-hmm.
Anyway.
Yeah.
One day.
The link that I dropped here, which links to the TUI Toys branch of the Urbit repo. This is the branch that has a few demos, including like command line snake and like a slide package and some other things that.
Yeah, TUI is text UI to Daniel who asked the question.
So, yeah, there's a lot of possibilities there, and if anyone really, probably. The most difficult part, honestly, is probably styled text. You can do it just fine, and Track7 shows you how to do it, but the data structures for it are kind of weird and terrible and unintuitive. So, you know, look at that's an area where I think that could also use some improvement as well.
Anything with color?
Yes. Track7 shows color. So Track7 builds a CLI where any text you type gets printed 80 characters wide in random colors. So
yeah, color is easy in curses, but other things are not so easy.
I mean, Dill actually provides pretty good support for all of this. In some ways, Dill is actually limited by the terminals itself because we don't have a good way of connecting different terminal sessions to a particular terminal emulator. But anyway, yeah, this gets you into a whole other field of what would it look like to build really proper command line support on Urbit. So you'd have something like curses. The parsers are there, so that's pretty straightforward. We have a regex library. We don't really have a noun aware bash equivalent, right? Like I think actually having a Dojo upgrade would be nice to see, or maybe just a new shell that's not Dojo. Like Dojo does what it does very well, but it's pretty bare bones in that, like, I can't get the noun out of one program and immediately compose it into a different program as an input, for instance. So I think there's some possibilities there too for building new and interesting kinds of interfaces. Maybe passing it through mark transformations or something.
Yeah, so Dojo is mainly black with a tinge of gray, right? Like it's a stark contrast to using an IDE and having everything syntactically colored.
Mm-hmm. Yeah, it doesn't give you any highlighting on your Hoon. That's for sure. I mean, other than the fact that we incidentally use it in Hoon School, or we use it to test particular lines of code, I don't know how common development at Dojo is, but yeah, it'd be nice. It'd be nice to see a little bit more like that too. That'd probably be a good, hackathon-sized project. Can I modify Dojo to give me syntax highlighting? Seems like you could. So, all right, that's 75 minutes. So let's call it for this week.